The first part of this question is about harmonic series or writing things in the form k, like writing a combination of cos and sine is a single cos or sine function, in this case, cos. So this is a method that you should have practiced many times, so you should be ready for it. But here I am to go through it. Okay, so we want to write the left-hand side in this form. So what I'm going to do is expand the cos theta plus alpha using the addition formulae. Cos A plus B is cos A, cos B, minus sine A, sine B. That is in the formula book. So here we will get K cos theta cos alpha minus K sine theta sine alpha. And I'm basically saying that this is equal to that. And so I can now compare coefficients. It must be that the coefficient for the coses are equal, and therefore K cos alpha must equal 140, and the coefficient for sine theta, they're equal. Both got a negative in, that's why we've used cos theta plus alpha. So K sine alpha is going to equal 480. If you're not convinced by equating coefficients, then another way to explain it is that this is true for all values of theta, and you could substitute different values of theta in. And if you, for example, substituted theta equals 0 in, then that term and that term would disappear, and then cos would be 1, and then you get exactly the same thing. And the same is true if you substituted pi over 2 in, then this one would disappear, and this one would disappear. Sine pi over 2 is 1, and you'd get our second equation. So you've just got to learn to accept, and well, not just accept, but yeah, realize that must be the case because it's an identity and true for all values. This is the case. Okay, now we're going to find out k and theta. So the way I like to explain it, there's lots of different ways you can do it, but a nice one involving understanding is to rearrange sine. Let's start with sine alpha one, and I'm going to divide through by k. So now if I identify this acute angle in a right angle triangle, then I'd have the opposite as 480, and I'd have the hypotenuse as k. And if I do the same with cos theta, I'm going to get 140 over k. So now the adjacent would be 140, and this has to be the setup. So then we just see that k is going to be 480 squared plus 140 squared square rooted. And that ends up being 500. And then I always go with tan. I mean, you could use tan, cos, or sine at this point, but if I go with tan, then just in case I made a mistake with that k, I'll get this next bit right. So tan alpha is then going to be 480 over 140. Now, we're working in degrees here, so make sure your calculator's in degrees. Do inverse tan, and we get 73.739. And therefore, I've got 500 times cos theta plus 73.74. We are asked to state the value of k. So I'm going to do that. I think I'd get away with it because it is implied, but let's just state it. And then alpha is this 73.74, and it's all good. We're there. That is something we've seen before, but it is absolutely essential for doing the whole rest of the question. So you've got to get that bit right. Now, onto the modeling part. So scientists studies the number of rabbits and the number of foxes in a wood for 1 year, and the number of rabbits is modeled by this equation here. T is the number of months after the start of the year, and A is some sort of constant. Given that during the year, the maximum number of rabbits in the wood is 1,500, we're asked to find a complete equation for the model. So the first thing I'm going to do is use our earlier part because you can see the similarity with what we did and what is here. So R is going to be equal A plus 500 cos. Now the only difference is that I need to replace theta by 30t. So because 30t plus 73 point. Now, one thing I like to do is use a more accurate version. We've rounded it to two decimal places, but I always say to students and myself that, and this is true, this is not just me saying it, that you should use as much accuracy as you can and only round your final answer. So I'm going to go back to 70.739. If you don't, you'll get away with it, but I'm talking about best practice outside of just an exam here. Okay, so looking at this, I can actually write down the maximum value straight away because the maximum value of cos is 1. It can't go above 1. And therefore, the maximum value of that right-hand term is 500. And so the maximum value overall is going to be a plus 500. And we know that actually the maximum value is 1,500, so a must equal 1,000. We've got ourselves our equation. R is going to equal 1,000 plus 500 cos 30t plus 70. I've not got enough space here. 73.739. Brilliant. Hence, write down the minimum number of the rabbits. So this is going to be when cos hits its minimum, and that is -1. So it will be 1,000 minus 500 instead of plus 500. The minimum is therefore going to be 500. The actual number of rabbits in the wood is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. Now, there's a couple ways you can do this. I decided to find out where the minimum occurred for T. You could alternatively work out T for the middle of April and substitute it in and then check your value with R. That is arguably a little bit easier. So I will go, oh, do you know what? I'm going to go for it both ways. Right, it's got to be careful. Middle of April. So the start of January would be T equals 0. February would be 1. March would be 2. April would be 3. The start of April would be 3. Even though it's the fourth month, the start of it is T equals 3. So the middle of April is going to be T equals 3.5. So when T equals 3.5, R is going to equal, and now you've got to sub in here. So my calculator, well, it's not in the right mode at all at the moment, so I need to go back to calculate, and then I go to settings to change it back into degrees. Okay, maybe you've already got yours in degrees. Right, then I'm going to go back. Okay, so now I've got 1,000 plus 500 cos 30 times 3.5 plus that 73.739. And this gives, wow, 500.12. And this is, I mean, you cannot argue with that. This is very close to 500. So the model is reliable. I mean, I would say it's reliable on this aspect. It doesn't mean it's reliable in general, but you will be okay to just say it's reliable. Reliable with this fact. Just to return to my alternative method that I wanted to share, and another time you might be asked to do this, so it's not like a waste of time or anything. We could find out where the minimum occurs. You know, if we, in another time we might just say, when does the minimum value occur? And for that, what we've got to do is think, where does cos hit its minimum? And it's actually going to be, so it looks like it's actually going to be when it's 180, when the argument inside is 180. So we could solve 30t plus 73.739 equals 180. And then do 180 minus 73.739. That gives 106.261. divide by 30, and we get t equals 3.54. So then we see again, it's, yeah, just around the midpoint of April, just after like the middle of April. So that's another way you could have done that question. Now we're on to the final part. So the number of foxes in the wood during the same year is modeled by this equation. And the number of foxes is at its minimum value after t months. Okay, so actually this question is forcing us to do the method I just said. Find, according to the models, the number of rabbits in the wood at time t months. So, right, this time I've got a sine going on. So sine actually hits its minimum at 270. Okay, because so that the minimum value of foxes is going to be 30 when sine is -1, which gives us a -70 here. But the point is that sine is going to hit its minimum when the argument inside here is 270. So I need to solve 30t plus 70 equals 270. Minus the 70, that's 200. Divide by 30, I get 20 over 3, which is 6 2/3. So, but we don't need to relate it to the number of, what month that is or anything. All we've got to do is substitute that back in to here. So I will actually return to my calculator here because I had it like already. Okay, so this time, instead of 3.5, I'm going to be putting in 20 over 3. And that will give me 1032.6. Now, that little debate is like, should we round it up? Because obviously we can't have a fraction of a rabbit, or because we haven't quite got to 1033, should we actually truncate it and make it 1032? And both are accepted. I feel like I want to round up. Like if you had 0.99, I'd be like, well, we pretty much have 1033 rabbits. But I understand why it might be truncated as well, because you could say you don't quite have 1033 rabbits, so we're going to go with the number lowest. But like I said, both be accepted. That is how we can deal with that very last part.